first thank the organizer of this fascinating conference. As you mentioned, this is my first time I attend this conference. I regret I missed your previous conferences. I've been working in application of Bayesian Network for last 10, 15 years. And today, Reza is presenting part of his PhD project, which generally is about startup evaluation and startup portfolio optimization. Part of his research is about optimization, but he's today introducing us one of the Bayesian network models he developed in order to startups. And later he is working to develop optimization models to incorporate the result of the Bayesian network in optimization and mathematical programming models. So I leave it to Reza to explain his model for you.
It's my pleasure to be here with you today. Let me briefly introduce myself. My name is Mohammad Reza Valaei, and I am delighted to be here today to talk to you about startup lifespan assessment by using Bayesian Network. As you know, Vahid is my PhD supervisor, and he's associate professor at Bayesian University, and I am a PhD in industrial engineering. Today, I'm going to present our network model for estimating the default rate of a startup. I will start by telling about risk breakdown structure. Then I'm going to move on to explain how my model is designed. And finally, I will demonstrate what is the output of model and how we validate the proposed model. As you know, almost 90% of startup fail. Really, it is a huge default rate, but it is a real story. Venture capital portfolio value depends on startups rather than average startups. Recognizing this issue may give additional insight into our default rate estimation. We find some complexity of the default rate estimation, which include lack of historical data, high level of uncertainty, dynamic environment, and expert opinion with cognitive bias. Survival depends on a range of factors. And the last one is a credit scoring model. As you know, there are many causes for failure of startups, but we use the method risk breakdown structure for determining the most important failure factor. In this slide, there are 3 levels of risk. The first level is related to default rate. The second one is related to key factors. And the last one is related to sub-factors. Based on complexity of default rate estimation, we use BNs for estimating the default rate of a startup at each period of time. We have 4 periods for the default rate. And for example, 30% of all the staff fail at the end of first period, and only 87% of them will survive after the first period. And this process will be continue until the fourth process. Because we want to reduce the cognitive error of expert opinion, we try to make prototype a Bayesian network model. Then, based on general information, then make a special model for each startup, prototype model, create a baseline for other startups. For designing Bayesian network, a combination of 2 structure is used in our methodology. Firstly, external structure combines subcategories factored in key factor by using n from n structure. It means at least n from n subfactor must be done for activating key factor. And the second one, internal structure, use the noisy OR structure to combine key factors into the default rate. By using this structure, we can consider unknown risk factors such as industrial risk or economic condition in the model. For validation framework, we consider 4 sections. The first one is assumption, and the second one is input parameter value, and the next one is output value, and the last one is results value. For illustrating the estimation performance of the BN model, we use a receiver operating characteristics curve. You know that the area under the curve here, this area, is our index. If it is between 7 to 80%, it's acceptable. And if it is between 80 to 90, is regarded as excellent, and it's above 90%, it is almost perfect. And AUC of our model is about 76%. There are some case study for showing the result of a model. And the first cases showed startup at IT area. The startup was founded 3 years ago and generate a revenue, but in an evil manner. And so the value of noise is set at 50. It means feeling noisy. It's 15%. And the parameter M is set to the parameter M is set to 2 for all factors. And the top 5 significant sub-factors identified were powerful competitor, political or economic, legal problem, lack of funding, not having investors, and too many competitors. Therefore, the startup founders and investors should pay attention to these top 5 factors. And on the other hand, maybe we can image and tend to reduce the default rates. However, they cannot decrease some factors, and as a result, other key factors should be changed using backpropagation features of BNS model. Each factor is determined as shown in the figure. And this is another example of startups. Its field is tech fields, and this result is shown. We want to talk about future study, and future study is encouraged to evaluate the effect of combinating the result of our estimation with a portfolio credit risk model. And another one is aspect that can be added to model is the impact of general support policies such as subsidized anti-crisis fund and grants on the survival of the startups. And the last one is using the dynamic Bayesian network structure. Okay, thank you for your listening.